Well, good morning, everybody. I'm actually really excited to talk about elasticity. I think that this chapter does a really nice job, a better job than actually I got, I think, when we first covered this when I was in school. So I think that this is going to be really good. I am going to encourage you to take a little bit of time on this, to do a good job, to go slow, to actually do the problems. I think it will help you, and I think you'll understand it better, and I will make sure you don't get lost as long as you are trying your best. So with that, let's actually dig in. Elasticity. Okay, and by the way, in class, I'm going to tell you this. I recommend you stop every time you hear the word elasticity, and instead you think of, instead of elasticity, I want you to think of sensitivity. And what I mean by this is sensitivity between two things. So if we say price elasticity of demand, elasticity, that just sounds scary. What the heck does that even mean? But as soon as I clarify what that means, and I say the price sensitivity with demand, all of a sudden you go, okay, that kind of makes sense. Like I can kind of grok that. Okay. The next thing that I want you to know is that there are a lot of different elasticities. Typically when we just say, is it elastic? Is it inelastic? You'll know what I'm talking about, or we're talking about price elasticity of demand. So that's the one we're going to cover the most. But the other ones are not scary, and they're actually really easy. And one of the things that I hope I do in class is just show you the 4 or 5 different kinds so that they're not scary to you, right? And you can make them, and I'll just tell you a couple of them now. There's income elasticity, which actually makes sense because it just means if I get a bunch more money, do I spend more on this or do I spend less on this? This is how we determine inferior and normal goods. There's cross-price elasticity. That's how we determine if something is substitutes or complements, right? If the price of one goes up, what happens to the other one? And then the two big ones are price elasticity of demand and price elasticity of supply. And those are the ones we're going to go over mostly today. Okay, so what is elasticity? What kinds of things can it help us with? What are the two big kinds? What are income and cross-price elasticities, like I mentioned? What is the price elasticity of supply, and how is it related to the different curves? All right, let's use a scenario here. You maintain the social media accounts for local businesses. You charge P equals $2,000 per business, and currently maintain the social media accounts for Q equals 12 businesses per year. Okay, so you're getting $2,000 for each of these businesses. They're each, I have 12 businesses. Your costs are rising, including the opportunity cost of your time, so you consider raising the price to $2,500. The law of demand says if you raise your price, you will not have as many accounts to maintain. How many fewer, and how much will your revenue fall, or might it increase? These are all really great examples of questions that you're not going to be able to answer these questions explicitly and clearly and precisely unless you have some sense of elasticity. So, elasticity, as I mentioned, is sensitivity. It's a measure of how much buyers and sellers respond to changes in market conditions. It's also a measure of the responsiveness of quantity demanded or supplied to a change in one of its determinants. So the price elasticity of demand is how much the quantity demanded of a good responds to a change in its price. Loosely speaking, it measures the price sensitivity of buyers' demand. So I like that they said it's a little bit loose, but sensitivity is a good way to think about this. Okay, so let's look at this. How do we define the price elasticity of demand? Well, this is why we've been doing all of that percent change. And actually, our formula is going to be easier than percent change, but it's a really good preparation for what we're going to do right here. So if the price rises by 10%, the quantity will fall by 15%. And so you can immediately see that the price elasticity of demand is 15% divided by 10%, which is 1.5. Super duper easy. Along a demand curve, price and then it doesn't say anything. I think it says quantity move in opposite directions, which would make price elasticity negative. Now, this is just an old thing we do in econ. We all agreed on this. We never use the minus sign. We just drop it and we report them as absolute values. Now, technically, it will sound like we say something like 1.5. Well, we all know that that actually means negative 1.5. That's a negative elasticity because there's a negative relationship. We're all just going to say it's an absolute value of 1.5. It's not that it's positive numbers. I think it's better to think of it as an absolute value. Okay, so the standard method of computing the percentage change in a variable is end value minus start value over start value times 100. That's fine, and that works pretty well. Okay, but what we're going to do that's a little bit, I think, better is we're gonna do something that's a little bit clearer. And let me explain why this doesn't always work. Depending on where we start, we can get two different answers. So look at B and A, and they've given you the answers here. So if you want to calculate it, pause it and do that. But look what happens when we go from B to A. We get a different answer. And they've calculated both of these correctly, but you're going to get a different answer in both of these. You're going to get 1.33 and 2.5 in the other. Okay, so the reason why we're going to create something else is so that it's a little bit easier and a little bit more consistent, and that method is called the midpoint method of calculating the price elasticity of demand. And the way that this works is we take a number halfway in between the two, and we average the two values. And that actually, like, it looks a little bit scary, but just go slow. Q2 minus Q1 over Q2 plus Q1 divided by 2. Again, we're just literally creating the average of the two. Okay? And then you do the same with the prices. P2 minus P1 over P2 plus P1 divided by 2. You're literally calculating the averages of the quantity and the price and then dividing the two. And it's pretty darn easy to do that. So, by the way, I actually prefer the delta sign. So Q2 minus Q1 is just a lot to remember. I like delta Q and I like delta P, and that just means the change in the two prices. And then the average of the two quantities and the average of the two prices. And that's just a little bit easier for me, okay? All right, in fact, I wonder, should I go, you know what, in class, remind me if I don't, the easier way to represent this is to say Q bar and P bar, which means the average of the two, and then delta Q and delta P. It's just a much simpler formula. It'll be easier to remember. So remind me later and I can show that to you. It's just a little bit less scary. Okay, in our scenario, we've got calculating some percent changes. We've got some stuff that's going on. We're going to use the midpoint method. So let me just show you how this works. You can already kind of tell where the midpoint is going to be. Okay, so the change in P, let's do the percent change in P first. We're going to do from 2,500 to 2,000. And then the average, the midpoint between the two. And you can just find that in your head. That's really easy. It's 2250. What about the percent change in Q? Well, that's pretty easy too. It's 12 minus 8. And the in-between of those two is going to be 10. Now you've got your percent change in P, your percent change in Q, and the elasticity is really easy. You just divide the two, and in order to get the answer, we get 1.8. That tells us the price elasticity of demand, okay? Which again, informally, we're just going to say the word elasticity, but that's all that's going on. Now, by the way, I need to say this because there's probably 10 of you out there who are going, oh my gosh, this is so much math. I am so confused. I know that it doesn't sound like it, but for some of us, it's easier to do the long division even when we have no idea what's going on and we just do it step by step. Go through and do these problems if they are hard for you. This chapter actually does a really good job giving you lots of chances to think through the intuition side. This right now is the rational, more the algorithmic side. So don't give up. You can do this. Keep pushing yourself, but we'll get to the other stuff in just a minute. Okay, let's do active learning 1. Here's your first opportunity to do this for yourself. I'd like you to use the midpoint method to calculate percent change in price, then the percent change in quantity, and then calculate the price elasticity of demand. So I'm going to give you a couple of minutes, do this on your own, and then we will go over the answers. All right, here we go. Using the midpoint method, you're going to do percent change in P first. Well, first of all, this should have been really easy for you. The percent change in P is 600 to 400. That's 200. And then the average, the midpoint between the two is 500 times by 100. That's 40%. Okay, the change in quantity, percent change in quantity demanded should have been negative 23.16%. It's a little bit messier numbers. Don't give up if you get messy numbers. In fact, in real econ, you're going to get messy numbers all the time. If you ever get a really even number, it kind of freaks you out. Okay, now in order to find the price elasticity of demand, should be relatively straightforward. You should have gotten 0.58. Again, we use absolute values. We all know that it's always going to be negative. That's fine. We just move on with our lives. Now let's talk about the determinants. In other words, this is where we're going to start getting into what makes sense and why is this useful. So let's look at each example and figure out what's going on. Suppose the price of both goods rise by 20%. Which good has the highest price elasticity of demand and why? What lesson do we learn? So I love this part. He's going to go through, the author of the slides is going to give you an example to make you think about why might one or the other have a higher elasticity and why, which one is more sensitive to price changes. And so what I want you to do is I want you to think, and I want you to pause if you need to so that we're not giving away the answer, okay? All right, Cheetos and airfare. Imagine that both of these prices go up by 20%. Which one is going to drop the most and why? Okay, so go ahead and reason through this as best you can, and I'm going to reveal the answer once you unpause it. All right, here we go. Cheerios have lots and lots of substitutes. So if Cheerios go up, what are you going to do? You're going to stop buying Cheerios right away. You're going to buy cornflakes. It's not a big deal. But for airfare, there aren't a lot of close substitutes. Driving across the country is just not the same thing. It's too expensive, takes too much time. Even trains take too much time and they're more expensive. So it's not going to change prices very much because when you need a flight, you just need a flight. In fact, most of the time people take flights when they need to get there quickly. Here's the key lesson. Here's the idea here. Price elasticity is higher when close substitutes are available. In other words, people are more sensitive when they can. In fact, one of the ways to think about this is E stands for escape, meaning elasticity stands for escape. And what this means is if there's an easy way to escape, then the elasticity is going to be much, much higher. You're going to be much more sensitive if you have an easy way to escape to something else. Let's talk about Mountain Dew versus soda in general. Prices of both of these goods rise by 20%. For which good does QD drop the most and why? Go ahead and pause it, reason it out, and then let's come back. All right. I hope that this is obvious. If the price skyrockets of Mountain Dew, if it's like $10 per can, and by the way, it's helpful if you just imagine a 10-cent gain. I've said this before. A 10-cent increase in price is not enough to actually make sense of most of these. You want to make it a really, really big change in price so you can reason through it. Imagine the Mountain Dew goes up to like $10 per can. Well, you're going to just stop buying it, right? Like you're going to buy other stuff. You're going to find something else that's better for you. And you've got a lot of stuff that's out there, lots of good substitutes. So for a narrowly defined good like Mountain Dew, there are lots of substitutes, but there are fewer substitutes for pop itself or soda itself, right? If root beer and imagine that it's the carbonation that's become more expensive. That means that, if you want soda, yeah, you can get water, but that's not really the same thing as like a nice drink that's got a little bit of buzz in it, right? So here's the key lesson from this that you might already be able to derive. Try and do this yourself. But let me reveal the answer. Price elasticity is higher for narrowly defined goods than for broadly defined ones. And so you can set this down in your book. This is a good general rule of thumb. For narrowly defined goods, price elasticity is going to be much higher because you can just switch to another kind. So if it's one kind of ketchup and another kind of ketchup, if the one kind goes really high, you're going to be very sensitive and switch to something else. But on the other hand, if it's all ketchups, well, mustard is related, but it's not really that good of a substitute. You're going to pay for a more expensive ketchup most of the time. Now let's look at insulin versus Rolex watches. This is a really, really important one. Again, imagine the prices go up by 20%. For which good does QD drop the most and why? Okay. Go ahead and pause and think this through. Okay. Insulin is necessary for diabetics. A rise in price would cause little or no decrease in quantity demanded. This is paying for your life. This is literally, I have to have this or I'm not going to be able to survive. And so because of that, if the prices go up, you're hosed, but you're going to pay for that drug because it's really important to you. A Rolex watch is not the same. If the price goes up, then most people will just go, well, I guess I just don't need a Rolex right now. Here's the key idea here. Price elasticity is higher for luxuries than for necessities. The more of a necessity it is, the less likely it is that you're going to be able to shift away because you just need this. Okay. Let's talk about gasoline in the short run and the long run is another key idea. Imagine that the price of gasoline rises 20%. Does QD drop more in the short or the long run and why? Go ahead and reason it out and then come back. The answer is in the short run, there's not a whole lot you can do. You might be able to ride the bus or carpool, but you just don't have as many options. In the long run though, oh man, you can buy smaller cars, you can live closer to work, you can find a bike path. Here's the key idea. In the long run, price elasticity is always higher. People have more options. They'll find better substitutes over time. And that means that price elasticity is higher in the long run. Okay, this is very quick. It's not very hard to understand. Now we're going to connect this back to demand curve. So there are a bunch of different price elasticities. The price elasticity of demand, when it's greater than 1, we say that it's elastic. When it's less than 1, we say it's inelastic. And we call it unit elastic when it has a perfect price elasticity of demand. Okay? Now, there's also inelastic. So if price elasticity is 0, then the demand curve is vertical. We're going to draw some of these in just a minute. And if the demand is perfectly elastic, that means that the price elasticity is infinity and the demand curve is totally horizontal. You will never see that in real life. You will never see perfectly inelastic or perfectly elastic, but it is a lot easier to remember those. By the way, I'm going to say this right now. Actually, let me give it in a second. The flatter the demand curve, the greater the price elasticity of demand. Really, really important idea. Flatter is more elastic. If it helps you, when you draw a capital E, you draw a vertical line and 3 horizontal lines. The horizontal line is what reminds me that elastic is flat. When I draw an I, a capital I, that's inelastic. And that's what I think of whenever I see this. Okay, so this is perfectly inelastic demand. There's a 10% change in price. And what's going to happen to quantity? And the answer is nothing. So what does our price elasticity what is it going to end up being? The answer is 0. This is vertical. This is something like insulin. Now, if you increase the price enough, you're still going to see a change. If it's $1 million per bottle of insulin, people are going to run out of money. So it's only going to be very, very close. But if it was truly vertical, it's helpful to think about it this way. The elasticity is 0. Okay? Next, we have relatively inelastic demand. That is, it's still pretty steep, okay, and that's useful. Price drops by 10, your Q is going to rise by less than 10. It's only going to rise a little tiny bit, and that's because people just need this thing a lot, okay? Relatively steep, sensitivity is relatively low, elasticity is less than 1. Unit elastic demand is when it's going to be equal. 10% change in price, 10% change in quantity, okay? This is, you've got kind of an intermediate slope here. There's an intermediate amount of sensitivity and the elasticity is equal to exactly 1. This is when a 10% change in quantity and a 10% change in price go together. Now we've got elastic demand. This is where there's a lot more sensitivity because there's some good chances to escape. E for escape and E for elasticity helps me. This is substitutes, right? We've got a lot of substitutes. So if the price falls by 10%, then the quantity is going to rise by more than 10%. And the same is true in reverse. If the price goes up by a bunch, then you're going to lose a lot more. Okay, so relatively flat curve, consumers' price sensitivity is relatively high, and the elasticity is greater than 1. Obviously, we've got the perfectly elastic demand. This is where it doesn't matter what the change in price is. Doesn't matter. This is any change in price. Why did they say it this way? If there's, yeah, that's kind of weird. Price changes by 0%, I think is a weird way to think of perfectly elastic. The way that I think about it is an infinitesimal change in price and people are going to switch away really fast. They are so hypersensitive that even a tiny, a 1 cent change, they've got a ton of better options. This is like when you're in the store and you just look for what's the lowest price. You've got 5 different ketchups and you're not a ketchup snob, so you just pick the cheapest one there, okay? Okay, so this is another extreme. This is where you've got an infinite elasticity. By the way, this next slide, I'm going to break this video into 2 because I need to get up to school. So if you are listening to this, please wait and listen to the second video, which I will release later. But I think it's actually probably a good idea. You've probably got a little bit of exposure. You've got some sense of what's going on, and then I'll come back and finish with the second video. But I want to end on this next one because this is such a great little slide. Here are some real elasticities from the real world. You might think there are other breakfast foods for me than eggs, so why is it so inelastic? And the answer is because eggs are in everything and there aren't good substitutes. Eggs are fantastic. They're phenomenal. They're this wonderful, magical food that everybody uses all the time. That's why eggs are so, eggs are actually more inelastic than healthcare is, which is kind of funny. Now you're probably looking at cigarettes and going, why are cigarettes? Why don't people just choose to stop? Because cigarettes are addictive. And by the way, that's true of a lot of drugs. They're very, very inelastic because people can't choose to get away from them. Rice, housing, these are things that people just need. Now they're still responsive. If there's a big jack up in prices in housing, that people will try to wait for a little while. But you'll notice that beef, if it gets really expensive, people can buy chicken, they can buy pork, they can buy other things. Mountain Dew, we talked about this earlier. If Mountain Dew gets really expensive, people will buy other things. Restaurant meals are very much luxurious. If restaurants get expensive, then people will pay for more stuff at home. So these are real life elasticities. And by the way, there are things that are even higher elasticities. Things like super luxuries and things with just a bajillion different, another one that I heard of is screws at Home Depot. There are so many different versions of screws that are so cheap. And like you don't even think about the company you buy from. It's not like you buy from a certain nail company or a hammer company. it's so similar to each other that if one hammer is a little bit more or a little bit less, you're just going to buy the cheapest hammer. You're going to buy the cheapest nail. These are highly elastic. People are very, very price sensitive. Okay, this is great. We've gotten through about half the material. It'll give your brain a chance to think, and then I'll come back and finish up with the second half of this a little bit later. Okay, thanks friends. See ya.